Welcome back. So this is a video on the Level 3 NCEA Bivariate Data Achievement Standard, and we just looked at outliers, and now we're going to look at groups. So the idea of looking for groupings or subcategories within your data that have a different relationship or show different characteristics, and how we can fit a separate model to each of those groups. And if you want to get merit or excellence, you need to be looking at this. You should anyway, I think. So groups. This is from the notes in our workbook, page 37. And we're going to work through an example together. So this one is about flowers. So it's the Fisher iris data. So we're going to find out a little bit about that first. In the 1930s, Dr. Edgar Anderson collected data on 150 iris specimens. This data set was published by R.A. Fisher, the well-known British statistician, in 1936. And so, I don't know if you're interested in flowers or not, but this data set's just a really good one for actually showing how groupings can occur and what to do with them. And that's the reason why I've chosen this one. The first thing we need to do, if you've got this data set I have, this is an Excel format, and we want to get it in CSV format so that the statistics software can recognize it. So I need to delete this text and go save as a CSV document, which is just save as type, and we're going down to CSV comma delimited, and then Insight likes it. And it asks you to say OK lots of times. Then import it, the CSV version, of course. There it is. And the ones we want, let's have a look. It says we want to do, what sort of relationship is there between petal length and petal width for iris flowers? That's a question. So petal length and petal width. The predictive variable is petal width, so that's the x-axis. Response variable is petal length. So I want petal length as my response variable, variable 1, and petal width as my predictor variable. So what do you see in this plot? Well, the most defining feature is usually the one to talk about first, and there's two groupings. And so we're thinking, why might there be two groupings? And one of the things you should always do when you see two groupings is see if it's related to one of the other variables in your data set. And so to do that, you go add to plot and color, so code more variables, color by levels of, and you just try the other ones and see what you come up with. Have a play. So I've already got petal length and petal width, so I'm going to look at sepal width and sepal width and sepal length. So I can see some patterns in both of those. I've also got species. So if I look at species, now I've really got something interesting happening, right? So there's a clear pattern. So I'm going to definitely be talking about this one first. Sort of looks like a diagonal exclamation mark, doesn't it? So all the green ones in the bottom left, the sort of crimson ones in the middle, and all the blue ones on the top right is the obvious observations I see here. So specifically, the bottom left green ones are Setosa species, and the crimson ones are versicolor, and the blue ones are Virginica. I need to look that up. But I'm going to do some research. For the purpose of this video, we're just going to go through how to actually handle with this, though. So what I'd do now is I would actually just describe what I see here. I'd write down, and you can use a writing frame like OSIM or Weka, but I'd be describing what do I see, specifically what's going on, and things like the Setosa species tend to have petal widths less than 10, and I need to find out the units. And the petal lengths tend to be less than 20, and they're all less than 20. So, and again, units. Then I'd do the same with versicolor. I'd say the versicolor all have petal widths of about 10 to about 17 with units, and petal lengths from about 30 to about late 50s, and similarly with the blue one as well. So that's my specific evidence, And then I'd be doing some research to find out, firstly, how do I actually pronounce those words, and secondly, to find out what it is about those species that might cause their dimensions to be different. And essentially, the blue ones are the biggest flowers, aren't they? And the green ones are the smallest. So that would be what I'd do first. What I'm going to do, though, now is I'm going to try fitting a different model to each of those species, because the thing is, if you wanted to predict the petal width, the petal length of a flower, just probably more important than the actual upward slope here would be what species it's in, right? Because if it's a Setosa, then already you know that its petal length must be less than 20, right? So there's not a heck of a lot of point fitting using a model for the rest of the data points. So the most important piece of information is what species is it, and then after that, it's what relationship do I see within that species. That's the key point. So I'm going to go add to plot, and then I want to add trend curves, and I always start with linear, and then just sort of have a bit of a play. And I want to go for each level of species. See that blue line at the moment. Notice what's wrong with that blue line. It's not very valid for the Setosa species because it's above most of the points. It doesn't go through the middle of them, does it? So it's not a valid model if we want to predict Setosa species length based on their width. Also for the versicolor, it's not valid because it's too low. Well, its validity's poor, because most of the time, if we use that blue line, if we wanted to predict the petal length of a let's have a look of a versicolor flower that had a petal width of about 12, we'd probably be too low, because most of the points amongst the crimson ones are above that blue line. And it wouldn't be too bad for the blue ones, although probably a bit higher than most of them. So really we need a better model. So we're going to go fit for each level of species, and we get this. Notice at the moment it's forcing it to do parallel line trends, and I'm not happy with that with the crimson ones, the versicolor, because if you look at the slope there, it doesn't really, it looks like the model's too high around the 10 petal width mark and too low around the 15, so it should be a steeper line. So I'm going to untick parallel line trends. Now I'm a bit more happy. I'm a much happier chappy now. So now I'm gonna use those models, and what I'd do here in my internal is I would go back to the original model. I'd copy and paste that, or I'd insert it into my document. I would actually use it to make some model estimates, so that I've got something to compare it with. So I'd actually make my model estimate, probably a couple of them, using this model, go through the process and discuss that. But then I'd rip into it and I'd talk about how it's not really valid within the species, and it actually matters more what species the flower is than what its petal width is actually. So at that point I'd be fitting these models, and I'd be pasting this in, and I'd be revising my earlier predictions, and I'd be doing a prediction for each species and explaining how this new model is better, it's more valid, because it describes the relationship within that species far more appropriately than a single linear model did. Hopefully this is helpful. Ask your teacher if you have any more questions. One other weird thing I will show you though as well, color coding is one option. Before I go, I'll actually just show you something else which you can do, which is quite cool. So you can go subset. So I could have gone, if I get rid of the models for a start, so I'm going to remove the trend curves, and this time I'm just going to go subset by species instead and see what that does. So subset. So what that does is it just gives you a different visual picture of it. So if you want to see them separately, you can do it that way as well, and you can still fit models to that too. Like so. Or I could leave the species just as color-coded, and I could subset instead by something like sepal width. See what that does. And I might decide that actually, let's try sepal length. And really just have a play. What you're looking for is a relevance here. What's relevance and also usefulness in terms of predicting or explaining the model. If you subset and you get a really small sample size in one of the categories, it's probably not necessarily that useful, is it? Like here I've got one blue dot. Okay, it follows a similar pattern to the one on the right, but the bottom right, but it's only still one flower. So have a play, and definitely the really, really important missing ingredient that I haven't done here is what? It's research. You need to find out. In this case, I need to actually go and learn my stuff about flowers because I have no idea. But you need to go and do some research, because in order to get excellence, you need to be linking statistics and context together and going somewhere with it. It's not good enough just to do what I've done here. There's got to be context in there as well. And keep thinking, what was the purpose of my investigation? All the best.